Hi to all. Today's topic is meter bridge. This meter bridge, it is the practical form of wheatstone bridge. We already studied the theoretical part of wheatstone bridge and balancing condition of wheatstone bridge. Now, the wheatstone bridge is the concept. Its practical application is the meter bridge. Meter bridge is an instrument that is designed based on the wheatstone bridge. Okay, based on wheatstone bridge concept, the meter bridge is designed. Okay, the meter bridge is an instrument that is used to determine the unknown resistance. You have one wire, its resistance you want to find out, that we can measure by using meter bridge. We can also measure the specific resistance of a wire also. Let us see on what principle meter bridge will works. The working principle of the meter bridge is based on the balancing condition of wheatstone bridge. The balancing condition of wheatstone bridge already you know, that is, if the current through the galvanometer is 0, if Ig is 0, then the P by Q equal to R by S. Here I suffix G is the current through the galvanometer is 0. Okay, then the bridge is said to be balanced. At that moment the ratio between the resistances, right, P by Q is equal to R by S. Now let us go for the construction and working of the meter bridge. Look at here. This is the meter bridge diagram. The meter bridge has two L-shaped metal strips. This is one and this is the other. Two L-shaped metal strips. In between that two metal strips, there is one rectangular strip we have to place. When we will place one rectangular strip in between two L-shaped metal strips, there are two gaps. Gap 1, gap 2. In this gap, we have to place a wire whose resistance we are going to measure. Right? That is unknown resistance. A wire whose resistance you want to measure, that you can connect in the left gap at the both end. In the right gap, we have to place the resistance box. Here RB indicates resistance box. Resistance box, by using resistance box, how much resistance you want to keep in the right gap, that much we can keep. That means here we can keep the 2 ohm, 3 ohm, 4 ohm, how much resistance you want, that much we can keep. This is the resistance box is connected in the right gap. The resistance box resistance is S, unknown wire resistance is R. This R is unknown, that I am going to find out, question mark. R is equal to question mark. And now in between the two L-shaped metal strips, there is 1 meter length wire is there. This is the manganese wire. Manganese is a alloy, it's a resistance wire. Okay, and from the center of rectangular strip, one galvanometer is connected. This galvanometer is connected to this HR. HR indicates high resistance. High resistance. What is the use of this high resistance? It protects the galvanometer. Galvanometer is used to measure the small currents. This galvanometer is protected from the large currents. If any by mistake, if large current passes through the galvanometer, then it can be damaged, because galvanometer can measure only small currents. If any due to wrong circuit connections, if large current passes, then the galvanometer will damage. To protect from the damage and from the large currents, then we are connecting one high resistance in series to the galvanometer, that reduces the current, then that protects the galvanometer from damage. And the end of the high resistance is connected to, right, jockey. This is said to be jockey. Jockey means it is a metal. Okay, it's a metal tip. It has a metal tip and it totally inside metal will be there. It's a, to make a closed circuit we are using the jockey. And the both ends of the L-shaped metal strips we are connecting to battery through the plug key. Okay, this is the construction and how it will works, and what is the use of this meter bridge. Meter bridge is simply, it is depends upon the wheatstone bridge. Okay, simply it depends upon the wheatstone bridge. It is used to measure the unknown resistance and specific resistance also. We can also measure the specific resistance. Okay, specific resistance, already you know what is specific resistance or resistivity. Then how to find out? What is the procedure? Till now I explained the construction. Now let us go for the procedure. How to find out the resistance and specific resistance. For that, what you have to do? I am telling that this is the practical form of Wheatstone bridge. How it will be practical form of Wheatstone bridge? Already you know Wheatstone bridge. This is P, this is Q, and this is R, and this is S. Then in between them one galvanometer is connected, right? P, Q, R, S. In between them one galvanometer is connected. Here one battery is there. This is the Wheatstone bridge previously we discussed. If the current through the galvanometer is 0, right? If current through the galvanometer is 0, we write P by Q equal to R by S, right? Okay. Now, if you take this as R and this as S and this as P and this as Q, then what you will get the formula? The ratio of these two resistances R by S is equal, we will get R by S is equal, we will get P by Q, right? Ratio of these two resistors equal to these two resistors. But in Wheatstone bridge we took that this is P, this is Q, this is R, this is S, then P by Q equal to R by S. P by Q equal to R by S means R by S is equal to P by Q. There is no problem, right? Let us see here how this circuit is similar to this one. Okay, this is the circuit concept that we discussed in the Wheatstone bridge. And now this is a practical application. Its practical form is this one. It is also similar to this one. Look at here. I will tell the 4 resistors how it will be. Okay, in previously we discussed this is P, this is Q, and this is R, and this is S. There are 4 resistors are there. Here also we see the 4 resistors. Okay, and this is R is one resistor. And this is S, S is one resistor. That means if you will write the equivalent diagram for this, how you will get? Okay, look at here. And here R is there, here S is there. That means we can draw like this. R, like this R we write. R is connected to what? R is connected to S, and this is S. And the S end is connected to meter bridge wire. This 1 meter wire has some resistance. This jockey okay, look at here. Here we have the jockey, right? Jockey. When we press the jockey on the meter bridge wire, this is a meter bridge wire from A to B. Its length is 100 centimeters. And when we place the jockey at here, jockey left side wire has some resistance. Its resistance we can take as P. This wire resistance I will take as P. And jockey right side also some wire is there. Right? Its resistance I will take as Q. Okay. That means the S end is connected to Q and P and R end is connected to P. This wire has some resistance P. And this wire has some resistance. Jockey divides the meter bridge wire into 2 parts. Left side wire resistance P, right side Q. Okay. Then S is connected to what? S is the resistance of the resistance box. S is connected to Q. Right. This is Q. And the Q end, this is the Q starts at here. And Q end is connected to P. Right. The P is, this is P. And the P end is connected to R. Right. Here it is connected to R. And now, in between the R and S, where the R and S are meeting with each other, here look at here, here R and S is meeting, R coming here and S coming here, S is the resistance of this one, right, resistance in the right gap. Here the meeting, where they are meeting with each other, R and S are meeting at here, from there it goes to galvanometer, right, look at here, from there, where the R and S are meeting with each other, there it goes to galvanometer. The galvanometer goes to, right, in between the P and Q, this part I said, this part of wire has a resistance, it is P. This part of wire has a resistance, that is Q. That means this is the midpoint, right? This is some point, okay? And now it is connected to a point where the P and galvanometer is connected to a point where the P and Q are touch with each other, right? Okay, like this. And now battery we are connecting between R and S. R and P. Here R is there, here P is there. Between R and P there is positive terminal of battery. Between R and P it goes to positive terminal. and the next it goes to this, between Q and S it goes to negative terminal. That means this is exactly equal to Wheatstone bridge. But in the above RS is there and below PQ are there. At that moment, how to write the Wheatstone bridge principle? It was very simple. When the current through the galvanometer is 0, if P, Q, R, S are there, then we write this by this equal to this by this. That means we write here formula R by S is equal to P by Q. It was very simple, right? That means this meter bridge, this is the meter bridge. It is practical application of Wheatstone bridge. Wheatstone bridge converted into device. That device is meter bridge, right? Okay. Now, how to find out the unknown resistance? Let us start. To find out the unknown resistance, what we have to do? Okay, we have to adjust the PQRS and make the galvanometer current as 0. Where we have to adjust the PQRS? Here unknown resistance, that is fixed. Resistance box, it is fixed. But here we can press the jockey at here. You can press the jockey at various points. And jockey left side wire, this wire. Okay, this wire. Resistance is P. Jockey right side wire, this is the jockey. Right side wire resistance is Q. That means if you press the jockey at here, this much length will be there, right? Its resistance is P. For example, if you press the jockey at here the jockey is there, then left side wire resistance will be increases. Okay, from where you are pressing the jockey, that point distance from left side increases. Left side wire resistance increases, right side decreases. When the jockey goes to right side, what happens? Right, this left side wire length will increases, right side of the jockey wire length will be decreases. Okay, this is the, for example, if the jockey is at here, okay, this is the left side wire length and this is the right side wire length. If the jockey is at here, then the left side is this much, right side this much. That means what happening? Left side wire length is increasing. That means P is increases because resistance directly proportional to length. And left side wire resistance we are taking P, right? When this length is increases, left side length is increases, at that moment automatically P will changes. That means what we have to do? We have to press the jockey at various positions. When you will press the wire at various positions, jockey at various positions, what happens? The balancing, not balancing, left side wire resistance P value, Q value changes. Why P value, Q value changes? P is the resistance of this wire, right? And this wire length increase means automatically resistance also increases because resistance proportional to length. That means by changing the P and Q values, by adjusting the P and Q values. How to adjust the P and Q values? Press the jockey at various points. Okay, press the jockey is pressed at various points on the wire. On this wire AB, we are pressing the jockey at various points. And at a particular point, the J galvanometer shows the zero deflection. At a particular point J, here I am pressing J. At this point, the galvanometer is showing the zero deflection. The galvanometer does not shows any zero deflection. Means galvanometer shows the zero deflection, right? Ig will become 0. Then the bridge is balanced. At that moment, we can take the ratio of resistance R by S is equal to P by Q, right? Okay. And now, here we write one thing that we know. What we have to do, at a particular point, the galvanometer shows the zero deflection. Jockey is pressed at various points. At a particular point, the galvanometer shows the zero deflection. You have to note that point distance from left end. That is this position where the galvanometer shows the zero deflection. That position is said to be null position, and the bridge is said to be balanced. Okay, and its left side length, this L, is said to be balancing length. Now we have to note the balancing length as L. This total length is 100 centimeters. Meter bridge, 1 meter length it will be there. 1 meter length means 100 centimeters. This is 100 centimeters. This is L. This will become 100 minus L. This L is called as balancing length because at this length, when you will place the jockey, at that moment galvanometer shows the zero deflection. That means the bridge is balanced. When the bridge is balanced, at that moment the length is said to be balancing length. Now we have to press the jockey at various points until the galvanometer shows the zero deflection. At a particular position, the galvanometer shows the zero deflection. That point distance from left end is said to be balancing length. That we have to note. Okay, right. Now here we write, we know okay, resistance directly proportional to length. What is the resistance of the left side? P. Its length is L. Okay, then P by Q we write. P by Q, P by Q, left side wire resistance by right side wire resistance is equal left side wire length L by we write as 100 minus L. This is equation 1. According to wheatstone bridge principle, what you know according to wheatstone bridge principle? According to wheatstone bridge principle, right? What is the principle? When the current through the galvanometer is 0, we write P by Q is equal R by S, right? This is equation 2. Now from equation 1 and 2, decide this is P, this is Q. P by Q equal to this is R, this is S. P by Q equal to R by S. But P by Q, P in place of P we write P length, and in place of Q we write Q length. Q length is 100 minus L. Right? We write from equation 1 and 2. What we write? P by Q we write as L by 100 minus L is equal to R by S. I want to find out the R. R is the unknown resistance. Then R is equal to what you will get? R is equal from this S into L by 100 minus L. Right? This is how to find out the unknown resistance by using what? Meter bridge. What is S in this? S is the resistance of resistance box, okay, or resistance in right gap, right? Resistance in right gap. Is it right? Now, what is R? R is the resistance in the left gap. Is it right? R is the resistance in left gap. What is the resistance in the left gap? R. R is the resistance that should be measured. That means unknown resistance, right? We want to measure the resistance. That is unknown resistance. Unknown resistance. Right? This is resistance in left gap. Resistance in left gap. Okay? This is resistance in right gap and this is resistance in left gap. What is L in this? What is L? L is what? L is the balancing length. L is the balancing length. This is how to measure the resistance. Once again I will tell how to measure the unknown resistance. It was very simple. Unknown resistance you have to connect in the left gap. And known resistance some 1 ohm, 2 ohm, S is unknown, known for us. Okay, then that we will keep it here 1 ohm, for example 1 ohm, and press the jockey at various points. At a particular point galvanometer shows zero deflection. At that moment you have to know the length L. Then you can substitute the value of S, that is known resistance 1 ohm we are taking. Balancing length some value you will get, that you can also substitute. Then you can find out the R. That was very easy to find out the unknown resistance, right? And now I will continue. You can take the screenshot and you write the notes. Let us see what is L in this. L, okay, L is what? L is the balancing length. L is the balancing length, right? Now let us see balancing length from where to where we have to take. From the left end we have to take. One side length is L, other side length is 100 minus L. Why? Because total length is 100 centimeters, right? Total length is 100 centimeters. That's why one side length L means other side length is 100 minus L. where L is what? Balancing length. Balancing length. Next, how to measure the specific resistance of a wire? Let us see how you will measure the specific resistance of a wire. Then for that, what is the formula for the specific resistance? We know already specific resistance, right? Specific resistance. What is the specific resistance formula or the resistivity? How to find out the specific resistance or resistivity? Balancing length is what, from where to where? AJ is the balancing length, right? Specific resistance formula, for example, this is a wire whose length is L and whose area of cross section is A. Area of cross section we write as pi r square. R is the radius of the wire. Its resistance, specific resistance formula is, it was very simple to find out the specific resistance. Okay, the specific resistance R is equal to, we write as, okay, what is the formula for the specific resistance formula? Specific resistance formula, specific resistance is denoted with the rho, right? Rho is equal to, we write as RA by L. This is the formula for specific resistance. Here we use the same formula. R is R, A is A, by L we have to take, L is the length of the wire. Here we can take capital L. Why we cannot take the small l? Because already small l means here balancing length. Okay, this wire resistance here we are correcting unknown resistance, RA by L. This we can use. We can also write the A formula here, that is R into A is area of cross section of the wire, that is pi r square by L. This is the formula to find out the specific resistance of the wire. Here R is the unknown resistance, right? Measured from equation 3. Okay, you see the equation 3, from that R we can measure, wire resistance we got, wire resistance we will get. Okay, and after that R, small r is what? Capital R is the resistance. Okay, what is the small r? Small r is the radius of the wire. Radius of wire. How you will measure the radius of wire? You have to use screw gauge. Okay, by using screw gauge we have to measure. Which instrument we have to use to measure? We have to use screw gauge. Measured by using screw gauge. By using screw gauge we can measure the small r. What is capital L? Capital L is the length of wire. Okay, length of wire whose resistance to be measured. Whose resistance to be measured, right? Okay, and these are the terms, and like this we have to measure the resistance and specific resistance by using meter bridge. Okay, now let us go for some more points regarding this. Okay, look at here. I am going to give some important points regarding the meter bridge. Okay, this is a note important points. First point is that if the resistance in the left gap increases, what is the resistance in the left gap? You know in the figure, right? This is the figure. This is the resistance in the left gap, that is R. This is S. Okay, this is gap 1, this is gap 2, this is left gap, this is right gap. Here there is one galvanometer and one jockey. This wire resistance P and this wire resistance is Q. This is balancing length, right? Okay, look at here. What we are doing at here, if the resistance in the left gap increases, look at here, this is the resistance in the left gap. If we increase the resistance in the left gap, or otherwise if the resistance in the right gap decreases, means this we are decreasing. If S decreases or R increases, then at that moment what happens to the balancing length? Whether it increases or decreases, whether the balancing point shifts left side or right side. What is balancing point? This point where we are pressing the jockey at various locations on the wire, at a particular location galvanometer shows the zero deflection. That point is said to be balancing point. Either bridge is balanced, this point is the balancing point. Whether this balancing point shifts to right side or left side, that is our question. If the resistance in the left gap increases, this we are increasing and this we are decreasing. Okay, if R increases or S decreases, then what happens to balancing length? Okay, the balancing point shifts towards right side. That means this new balancing point you will get here or here or here or here. That means the balancing point shifts to right side. Okay, why it is shifting? So it was very simple. From this figure also we can say that if R proportional to L, that means when R increases, automatically L also increases. L increase means if it goes to here, then L increases, right? That is L is the balancing length. That means L is increases. If we take this S to left side, R by S equal to L by 100 minus L. That means L is inversely proportional to S. Where S is increases means L is decreases, right? If S decreases means L increases, like that. Okay, simple. If resistance in the left gap increases, left side length increases. Okay, and if the resistance in the left gap decreases, if this is decreasing, R is decreasing, then automatically L will be decreased because R proportional to L. When the resistance in the left gap decreases, then this balancing length also decreases. Okay, that if the resistance in the right gap increases, then the right length will increase. When the right length increases means left side length automatically decreases. That means this case is that if the resistance in the left gap decreases, this is decreases and this is increases. When this is decreases, then automatically this will be decreases, right? That means the balancing point shifts to left side. Left side. This L is decreasing means balancing point shifts to left side. And the next third point is that meter bridge is more sensitive if the balancing length is nearly 50 centimeters. Okay, this meter bridge is accurate if the balancing length is 50 centimeters. At that moment you will get the accurate value of unknown resistance. And the next fourth point is that when we interchange the battery and galvanometer, here the galvanometer is there, the battery where? Here the battery is there, right? Like this, we will connect one battery. Here the battery and galvanometer if you will interchange, then already we discussed in the wheatstone bridge, if we interchange the battery and galvanometer, it will not affect the balancing condition. It will not affect the balancing condition, means it will not affect the balancing length, right? That means no change in the balancing length when we interchange the galvanometer and battery. That means if you in place of galvanometer we are placing the battery and in place of battery we are placing the galvanometer, at that moment there is no change in the balancing length. And the next fifth point is that when we interchange the resistances, firstly we interchange the galvanometer and battery, then there is no effect of balancing length. But if you interchange the resistances, this left side resistance will come to right side will come to left side. At that moment what happens to the new balancing length? Before interchanging, the balancing length is L. For example, S is taken to left side, R is taken to right side, then what is the new balancing length? The new balancing length I am taking L dash, that is equal to 100 minus L. L is the before interchanging. When R is left side, S is right side, balancing length L. When R goes to right side and S goes to left side, we will take this, we can remove from here and we can connect S to this side. We can connect R to that side. At that moment the balancing length also shifts. It will become, previously when R is this side, L is this side. When S is this side, then 100 minus L is this side, because total 100 centimeters. And this is L means this is 100 minus L, right? And when we interchange the R and S, then what happens? Balancing length also interchanges. It will become 100 minus L. Let us see its proof also we can do. For the fifth point I am going to give the proof. It was very simple. Okay. Now before interchanging we have to write one equation. According to meter bridge principle, unknown resistance formula we can find out like this: R is equal to S into L by 100 minus L we write. From that, before interchanging, okay, before interchanging, balancing length is L, right? We write the formula as R by S. R by S, this is taken left side. then you will get L by 100 minus L. This is before interchanging. But after interchanging, what we are interchanging? We are interchanging the resistances in the gaps. Means right side resistance will become left side will become right side. After interchanging the resistances, in gaps, then what happens? After interchanging, R become S, because in place of R we will connect S, in place of S we will connect R. Right? R is left side first, S is right side, but we are changing. S will become left side, R will become right side. Then R will become S, S will become R after interchanging. At the moment, new balancing length L dash I am taking L dash by 100 minus L dash, right? What I want to know? I want to know the L dash, new balancing length in terms of old balancing length L. Then further what we have to do? We have to use these two equations and we can find out the L dash. It was very simple. Let us see how to find out it. Okay, I am going to rub it and you can take the screenshot and note the points. Okay, and I will press the pause button and I will rub. Okay, let us continue now. From equation 1 and 2, what we have to do it here. Okay, and now here from equation 2, here S by R is there. Here S by R we write from equation 1. It will be reverses. Then we write in place of S by R formula we write from equation 1. That will become 100 minus L by what you will get? 100 minus L by L is equal to L dash by 100 minus L dash. What I did, do you know? This is S by R, but we know already R by S. You can reverse this. Okay, when you will reverse this S by R, you will get S by R is 100 minus L by L. Right, here we write S by R is 100 minus L by L is equal to L dash by 100 minus L dash. You can do the cross multiplication now. 100 minus L into 100 minus L dash is equal to L into L dash. You can multiply now. 100 into 100. 100 into L dash. 100 into L. L into L dash. Right? Is equal to L into L dash. This will cancel. Then we will get 100 into 100 minus 100 L dash minus 100 L is equal to 0. We will take this 100 is common and it will goes to right side, or otherwise we can do like this: 100 into 100 minus 100 L is equal to, we want to determine 100 L dash. We can take that side. We can take this term to right side. Then 100 is common at here. We will get 100 minus L is equal to 100 L dash. This will cancel. What you will get the L dash? Right. If you interchange the resistances in the left and right gap, then the balancing length will become 100 minus L. Okay. Firstly, before interchanging, left side resistance R, right side resistance S. After interchanging, left side S, right side R. Okay. Okay, now I am going to rub total and I will explain one problem and I will give the homework as one problem and I will close today's topic. Okay, look at here. This is our problem and it is very important problem. It's a previous CBSE problem, right? And it came many times in the last exams, and listen very carefully. Look at here. In a meter bridge, the null point is found at a distance 40 centimeters from A. This is a meter bridge. In this, null point is obtained from A. Null point means this is the null point where the galvanometer shows the zero deflection, and that point is to be null point or the balancing point. Its length is L, right? And that is the balancing length. In a meter bridge, the null point is found at a distance 40 centimeters from A, right? And the solution, let us see. The balancing length, initial balancing length, right? What they gave the balancing length, initial balancing length? initial balancing length is they gave 40 centimeters, right? Okay, when the left side resistance is R and right side is S, the balancing length is 40 centimeters. If a resistance of 12 ohm is connected in parallel to S, now what we are doing, okay, starting only balancing length they gave 40 centimeters. The starting there are only two resistors are there, right? One side S is there and other side is S is there. Now one side S and other side R. This is R and this is S. Now balancing length is obtained at 40 centimeters. Then what we write the formula? According to meter bridge formula, R is equal to, we know, S into L by 100 minus L. Okay? Right. Now from this we write R by S is equal to L by 100 minus L also we write. From this, left side wire resistance by right side wire resistance. And left side length by right side length. Right side length is 100 minus L because full length is 100 centimeters, right? Okay. Now R by S is equal to L by 100 minus L. Okay. Now R by S is equal to L is what? What is the balancing length? 40 centimeters by 100 minus 40. What you will get R by S? R by S we will get as 40 by 60. This 0 will cancel. 2 2 ja, 2 3 ja. Then we will get R by S as 2 by 3. This is before connecting 12 ohm parallel to it. Okay, just simply first line. In meter bits, the null point is found at a distance 40 centimeters. When left side R, right side S, the null point distance is 40 centimeters. R by S is equal to 40 by 100 minus 40. We got this equation. This is equation 1. Let us consider. Next, what we are doing it here. If a resistance of 12 ohm is connected parallel with the S, this is S. With the S parallelly we are connecting 12 ohm, right? Here S is there. Here we are connecting the 12 ohm in parallel, right? We are connecting 12 ohm in parallel. When you will connect the 12 ohm in parallel to S, right side resistance will changes, right? And the new balancing length is occurred after connecting the 12 ohm parallel to S. What happened? The null point occurs at 50 centimeters. The new null point, right? After adding 12 ohm resistance parallel to S, new balancing length. What is the new balancing length? New balancing length is 50 centimeters, right? It is 50 centimeters. That is L dash. Let us take L dash is the 50 centimeters. Okay. Now what happens to the formula? We write same formula. We write R by S is equal. We have formula L by 100 minus L. This formula we have to apply it here. R is equal to S into L by 100 minus L. Left side resistance is R again, no problem. By right side resistance is not S. Along with the S, 12 ohm connected parallelly, the effective resistance in the right side R by S, left side resistance by right side resistance. But right side resistance is now, what is the effective resistance of total? When there is no 12, right side resistance is only S. But here 12 ohm connected parallelly, now the effective resistance parallel combination R1 R2 by R1 plus R2. R1 R2, 12 into S by 12 plus S. 12 into S by 12 plus S. R1 R2 by R1 plus R2. R by S, left side resistance by right side resistance. Left side resistance by right side resistance is equal, right? After connecting the 12 ohm parallel. What is the new balancing length? 50 centimeters. L dash by 100 minus L dash. L dash is 50 centimeters by, right? L dash by 100 minus L dash we write. New balancing length is L dash. L dash by 100 minus L dash, right? Then we have to simplify this, okay? And for that, R into, this will goes to numerator, 12 plus S by 12S is equal to, L dash is what? 50, right? By 100 minus 50, new balancing length is again 50 we will get. Then this will be cancelled. Then we will get R into 12 plus S is equal, we will get as R into 12 plus S we will get as 12S, right? Now we write we want to find out the S, then for that we can write in place of R formula we write here from equation 1, 2 by 3S, 2 by 3S. From where I am writing this one? I am writing from equation 1, right? From equation 1 R is what? 2S by 3, this you write here. In place of R, 2S by 3 you write, and this S will cancel, and then from this 2 6 we will get, and then 12 plus S is equal, finally we will get as 3 6 18, then finally S is equal we will get as 18 minus, we have to simplify this, okay. I will rub this. We have to find out the R and S. Okay, we have to simplify that. What you are getting it here, 12 plus S is equal to, I am getting the 18, then S is equal to, I got as 6 ohm. Then this is equation, this we write, okay, S is equal to 6 ohm we got. S value substituted in equation 1, then R by S, what is the S value here? S value 6 is equal, we will get 2 by 3, 3 2s we will get, okay. Then finally R is equal to 2 into 2, that finally we got as R as 4 ohm. Like this we have to find out the R value and S value. R value is 4 ohm and S value is 6 ohm. Okay, this is our solution, right? And now it was very simple. I will explain once again. First, there is only R and S. R by S is equal to L by 100 minus L. Next, S along with the S, 12 ohm connected in the parallelly. Then R by effect resistance of this 12S by 12 plus S. This by this equal to new balancing length L dash by 100 minus L. You will get two equations. From that we have to solve this. Similarly, I will give one question and you have to solve it. I will close this lecture. Look at here, this is your question and its solution you have to write, okay, and write answer in comment, right? Write answer in comment. If doubt, contact my number 8309833096 or WhatsApp number 9963817138. Look at here everybody. And what is this our question? In a meter bridge, the null point is found at a distance 60 centimeters. This is the meter bridge. Here R is there, this S is there. Now the null point is obtained at L. Balancing length they gave 60 centimeters. Right here the null point, balancing point, its length they gave as 60 centimeters. Now what we are doing it here, if the resistance of 5 ohm, here resistance of 5 ohm is connected in the series with S. Here we are connecting the 5 ohm resistance in the series, not in parallel. In the previous question, we connected the 12 ohm parallel to S. Now we are connecting 5 ohm series with S. Right? Now the new balancing length is 50 centimeters. Then determine the value of R and S. Firstly here left side R is there, right side S is there. Balancing length is 60 centimeters. Then what is the equation? Left side resistance by right side resistance. R by S is equal this by this. L by 100 minus L. Now what we are doing? 5 ohm connected in the series in the right gap, that is S. Then what is the effect resistance? In series we have to add 5 plus S. What is the effect resistance? 5 plus S. New balancing length is 50 centimeters. Then R by right side resistance is, what is the effect resistance in the series combination? One equation you will get, that is R by, what you will get? 5 plus S. New balancing length L dash by 100 minus L dash. Exactly similar to the previous problem, and try to solve it Today itself you have to solve and send the solution in the comment. Thank you for watching my lectures. Till now, if you not subscribed my channel, then subscribe my channel and share to your friends. Thank you.